everyone, and welcome to the SWIM second day conference. My name is Sunil Sinha. I am a professor and director at Virginia Tech. First of all, I welcome you all for the second day of the SWIM conference in the COVID environment. We are doing in the virtual. Ideally, most of the previous year, we have done face-to-face in Arlington, Virginia, and hoping that next year we will meet face-to-face. Same in December, we do this conference. So I will go over overview what took place on Monday. We had a workshop, and then yesterday was the first day of the conference. We had excellent discussion with federal agencies and organizations, and today also we have excellent lineup of speakers and 2 panel discussions. So I will go over that. So I just want to give you a little bit brief on the title. What we are going for is the Smart One Water. So the Smart One Water came, this whole concept of this Smart One Water started last year when we got from National Science Foundation a planning grant to develop a, not just proposal, but also develop a community or a stakeholder who can help you to build this. And this is a part of not normal proposal at National Science Foundation. These are called ERCs, Engineering Research Center. Every 5 years, it's a 10-year kind of investment with multi-million-dollar every year. So it's a big investment from the federal agency because they are also responsible. They have to tell to the Congress why they are investing. So that's why they want to make sure that all national importance or societal impact projects can go forward. But it comes every 5 years. So what we proposed to NSF is, and we got the planning grant, Smart One Water. So what that really mean? So I will not read this, but this is directly from our proposal, Smart One Water Cyber Physical Social Infrastructure, ERC, which is Engineering Research Center, will transform the way people interact with water services, will advance measurement and decision. In short, basically to support management decisions in the water, looking in the more holistic way. I would like you to go to this website also we have created, because that's what NSF wants us to develop a website where all information, and we will upload after this conference, all information related to what we learned in this conference. It's www.smartonewater.org. So this website is created. It's not really a research website right now because it's based on the planning grant, but this website, as we go forward, this will become our main website for all activities related to Smart One Water. So what is One Water? If you look at this figure, we still have to make changes. We got a lot of feedback. So this figure basically is telling that the water with the services started in early 1800 based on the need, water supply, then wastewater for disease and all those, then stormwater, waterways, water cycles. So now in the 21st century, we have to look this not as an independent silo, but as a one water. So that's the concept. What makes it smart is when we looked at this, the whole water, it touches natural system, built system, what we call, and then socioeconomic. So, and then of course, there is a lot of events related to it. It's not like what we designed for, because if we design it well, it should perform. But the baseline has changed because of whether the climate change or other events. Pandemic is now affecting, so aging infrastructure is another thing. So how we take all this into consideration and look this as a more holistic, not just the different water domain, but also natural, built, and socioeconomic. To do that, we need digital transformation. So don't pay too much attention on this figure. A lot of discussion came how to improve this figure, the people aspect and all those. So we are working on it. So this is what we submitted last year. So we got a lot of feedback on this figure. But basically what this figure is giving you is digital transformation, how we can collect data from each silos. Data exists. I'm not saying all data, but data do exist to do a kind of a water cycle analysis. If you look at that, when we say water cycle analysis, it's the entire one water concept, which this slide is saying. To do that analysis, we need data from all stakeholders at some centralized, and that's where data governance and all those will come. NSF has also asked us not only to look into one water as a research part, most of the academic, as you see, research, but they are saying no. This ERC has to have 5 pillars. And this is what 5 pillars are. Convergent research, innovation ecosystem, workforce development, and stakeholder engagement. And in the center, what DOME we are saying, these are all 5 pillars: diversity and culture of inclusion, which connects all. So diversity is not just gender, but it's also a lot of discussion we had in diversity and culture of inclusion workshop we held on Monday. That diversity also of expertise. It's not just diversity, male, female, or different ethnic group, but expertise also. We don't want just engineers sitting there in the room, right? Social scientists, water touches many domains. So how to bring all those also. And then of course, culture of inclusion. We are trying to create a new organization where people shouldn't just come and stay there for 10 years, because we are talking 10-year initiative. So this is what workshop we held, as you can see here, in individual workshop. First was in Arlington. Some of you attended. That was face-to-face last year. Then we went virtual because of the COVID environment. So some of you participated in workshop, innovation ecosystem, governance. So those were all individual. We didn't do any formal workshop on research, convergent research. Again, the definition of convergent is different discipline. It cannot be just civil engineers or just water guys. We need to bring in all other sector in that. That's the convergent research. So we had a lot of internal group meeting. Then we held on Monday, December 7th, what we called workshop of workshop. And this also came from NSF, that we have to do one workshop of workshop where we combine all these, because these are not truly independent. Workforce, when we were talking workforce, there's a lot of discussion came innovation ecosystem, technology. We need a workforce to implement those technology. Then we need governance and implementation plan that comes from a stakeholder and others. So that's what we talked. We also talked a lot that what we will do in near term, midterm, and long term. And the key is, if we are going to engage all stakeholders, utilities, academics, federal agencies, state agencies, everyone has to be part of it. What we should do near term, and from NSF definition, near term is 1 to 2 years, midterm is around 3 to 5 years, and then 5 to 10 years. They also want to know what will happen to this organization after 10 years once federal funding is over. And that we discussed a lot, and we will talk that during the panel session. That's why every day we have the panel. So this was the workshop of workshop. As you can see here, the speakers, we had a full day on Monday, a lot of breakout sessions. So it was a workshop, so that's why we called it a workshop. So we had a lot of breakout sessions, brainstorming session, to get as much feedback as possible in each, and that we will discuss during the panel session. So swim conference is organized on the same theme from 8 to 10. So Tuesday, Wednesday, and Thursday. So we are on second day. So we will start with what I'm doing is welcome and overview. Then we went for the federal initiative yesterday. Organizational also we covered. Today we are going to cover water sector utility initiative. That what water sectors see this as a one water, smart water, intelligent, whatever term we use. Basically, we want to improve it, right? And that's the whole purpose of everyone, is how we can improve this management decisions and all those, so that we can deliver a good service for the societal impact. Tomorrow, we will touch on water sector industry initiative, what consultants or what service technology providers are doing. Then we have organized this panel. So yesterday we held the panel discussion on governance and implementation. We heard from Miami-Dade and from Netherlands, Amsterdam, that what challenge they are facing and all those. So that's kind of our, and then in the end we go with the swim award. We have the award. Face-to-face is more better, but we will do it virtual. So yesterday was, as you can see here, these were all lined up from federal agencies and from organization. Today, we have again lined up from utilities. So we are going to hear from them, because the key is why we are doing all this is to help utilities and water sector so that it can bring societal impact. And then you can see here, we have 2 panel discussions also, which we will go after the first session. Then we have break. During the break, we have our sponsors time, they will promote. And then tomorrow we will go again and hear from the organization. So couple of logistic is you will be muted, only you unmute when you have to talk. We will not take Q&A during the presentation, but after that we have a lot of time for open discussion and take your questions and answer. If And other is the sponsor is the key. That's why we run this. So Xylem, Mueller, Goagua, GHD, Jacobs, and you will hear from them during the break also, what are things they are doing related to Smart One Water. The contact is important. Before I stop, my cell phone and Kathy's cell phone. If you are having any problem logging in or during that, you need, best is to text us or even send an email. So with that, I will stop and hand over to Peter. Peter, you are there?
I'm here. Good morning.
Perfect.
Yes, thank you. Okay, well, for those who are virtually online, we are going to be going into the utility initiatives session. And I'm excited to kick off this session and listen to a diverse set of utility leaders across the country speak about initiatives they have been undertaking at their own utilities. Combined, the group brings decades of experience managing billions of dollars worth of infrastructure. And most importantly, the utility representatives of all the different stakeholder groups represent the front line of service. As we talk about the importance of smart water and digital transformation happening across the industry, I like to bring it back to what I would call home base, and really the central point of service, which is ultimately what our research and solutions and consulting is aiming to support. So with that said, we have each utility representative, they're going to give their presentation, and then we have a 30-minute group discussion. So please hold your questions until the discussion part of the session, or you can also put them into the group chat as well. So with that, we're going to start with Salil Karkar from DC Water. Salil, you can go ahead and show your screen. Salil is Senior Vice President of Operations, at DC Water, where he has been for over, I believe, 2 decades, and brings a great deal of experience in both operations, engineering, and organizational change management. He's going to be giving a talk about change management and the adoption of technology. Thank you.
Thank you, Peter. I hope you can see the screen and hear me at the same time. So let's start. So change management involves at least 2 of the pillars, or the 5 pillars that Sunil talked about: workforce development and stakeholder engagement. Now, a little confession here. As an engineer, this was one of the hardest things. It's an easy concept. It's a hard one to implement, and something that has to be learned. It doesn't come natural to most people, me included. But it's definitely, the key word here is adoption. If you have a new technology, a new concept, to get it adopted, you really need to go through some change management. It doesn't have to be elaborate, but there has to be some level of change management. DC Water. DC Water serves, distributes water to 700,000 folks within the District of Columbia. But on the wastewater side, it treats wastewater from 2.2 million folks, not only the district, but also 2 of the most populous counties in Maryland, as well as Northern Virginia. DC is known as very innovative. And if you look at the picture of DC there and look at the bottom of that diamond, the little green, all the innovation occurred down there at that little green dot. That's at the wastewater treatment plant. A lot of research work going into that plant that allowed us to build the world's largest thermal hydrolysis facility and operate it. Also allowed us to take a large risk and build the world's largest NMOX facility and operate it. Moving to the right, this is a 384 million gallon a day average flow plant. So you move to the right now, and on top of that, we just built an additional 225 million gallon a day tunnel dewatering plant and treatment plant to pump out of the tunnels and then treat it to secondary quality or better. And then play a balancing act between sending it to the plant if the plant is not at full capacity, or sending it to the river. And the lower picture is the river, something very proud of, that's Anacostia. Since the tunnels went online, we've removed almost 98, 99% of the water that would have gone into the Anacostia. It's tremendous. Bring it back to new technology. He's got to have a real problem that you need to solve. The continuous balances between the technology and application. Is technology chasing application, or is the application chasing technology? Once you come out of that loop, you go to implementation. Most folks would stop there and say, okay, we've implemented the solution. Well, you may have spent millions of dollars, but that's only maybe 20, 25% of what you've achieved. Unless you adopt it and you get adoption across the people that really use it, you haven't achieved much. And then the last part has to always be there, which is the evaluation and the performance. And it's hard sometimes. You look at technology you've implemented and you say, I spend millions, but it doesn't meet the mark. And to admit it is not easy, but you have to do that. And again, I'm trying to draw a differentiation between implementation and adoption. It's one thing to implement it, but without adoption, you haven't achieved much. The other thing that confuses a lot of people, me included, is the word technology and innovation gets thrown around a lot. You really have three I's in there. One is invention, where you're literally coming up with something new. You've got innovation, which is you're taking something that's existing and changing the value state. And then you got improvement, where you've taken something that's existing and just improving it a bit. All three are important. And new technology is not necessarily one or the other, but could be a combination of those three. And sometimes we do a disservice by just using the term innovation as something new and shiny. It doesn't have to be. But change is important, because you have to look at the frontline folks that take a look at your plant, or take a look at your facility and have known it for years. And then you have the engineering folks that have the theory behind it, and those two have to talk to each other. Right, the WIFM. This is just a very base example. On the left, you've got what you've known a high-tech variable width screen. Goes for anywhere from 1.5 inches to 18 inches openings. Not desirable, obviously, from a treatment perspective. You want to move to something more effective, like a 6mm screen. From an engineering perspective, it's a slam dunk. It just proves everything. Now you got to think about who's going to use it. From an operations perspective, you suddenly increase the amount of screenings, 20-fold increase in screenings. You got to think about the operations. So you've got to sell it to them in terms of what are the downstream impacts that you're mitigating to bring them on board. You look at the maintenance staff, there's almost to no maintenance on the left-hand side. On the right-hand side, you've got a series of motors, you've got solenoids, you've got conveyors. Worst of all, you've got a screenings brush that has to be maintained. And that's a nasty service. You just have to bring people on board. Moving on to, same thing goes with instrumentation. When ITA was a very viable organization, we worked with them very closely. And we tested instrumentation in the plant over 5-6 years before we used it. There was always this, you can't let the instruments make decisions. Great. Let the instruments tell you something and see if those are correct decisions before an operator makes a decision. We've moved from that to the point right now where we have ammonia-based control for nitrification, which is tremendous savings in energy. We've got a methanol control with a feed-forward, feedback loop. We've got the lowest methanol dose for nitrogen removal that we've seen anywhere. So it just helps, but you need to bring everybody on board, and that requires change management. And if you're a hammer, everything looks like a nail. So forgive me, my background's in pro-side change management, but there's 10 other change management processes. They all work the same way. They're all effective. This is automating the entire plant. There's a lot of fear We started with operators who didn't even know how to use a computer, worried about losing jobs. But to get the technology adopted, you have to bring them on board. You start by taking part of the organization, part of the plant, automating it, showing the benefits, bringing them up to speed, teaching them how to use computers, and you slowly bring them on board, which is what change management is about. But change management is not just for operations side or engineering. Maintenance is a big part of it. It's one thing to improve your technology, but if you don't have the maintenance staff behind it, maintaining it is be an issue. So you got to have a common language. We adopted the uptime elements from Reliability Web as a common language. And then you got to show them that it's effective. What they've learned is something they can apply. Typically, what would happen at a plant, you build a new facility, you take the O&M manuals, turn it over to a consultant. They would extract the PMs out of the O&M manuals, put them into your maintenance management system, and that's what they had to follow. Well, that doesn't work. When you teach them about maintenance, age-related is only 11% of the maintenance. 89% are random failures. So when you bring the maintenance folks on board and teach them that, you can do PM optimization. You suddenly reduce the amount of PMs they have to do, but you focus them on the right targets. And there's a goal for that. The goal is to look at your equipment, because that's where the rubber meets the road, and you want to make it last as long as possible. Now, the concept that equipment fails after 7 years, 10 years is really not a true concept. Equipment does not fail, ever. What fails is components within the equipment. So you start talking about mechanical seals, couplings, motors, VFDs, and you start talking about how do we take care of those components and find the failures. And that's about creating the change. For the seal, maybe it's just an inspection. You got to train the operators on how to inspect the seals. For a coupling, it's laser alignment. Train your staff on laser alignment, get them certified. On the bearings in the motor, could be ultrasonic or vibration. Get them trained on that. Teach them how that works. You don't have to change the oil every so many times. Take a sample, send it out to a lab. Get your maintenance folks trained on how to analyze oil, how to read the analysis from a lab. On the electrical side, use infrared. So all these technologies, to get them adopted, you got to first create the change, create the understanding within the staff that's going to use it. That's going to morph eventually to putting these online, but before you get there, you got to make sure that the people that are going to use it are bought into it. So change management principles absolutely need to be embedded, but not everything can be planned. This is from September 10th. We knew it was going to rain in DC. We didn't know how much. This was a hellacious rainstorm. We flooded the city, parts of it, especially up at the northeast side, got about 6 inches of rain. So that's driven us to create a change. Talking to other folks that were involved, getting their input. We're moving towards getting a real-time view on a 1 kilometer grid ahead of a rainstorm. Well, what does that do for us? Our call center got backed up with calls. You have management asking, where are the problems? You got the mayor's office calling. Well, you can take the calls and put them on a GIS space. And this is totally doable by our IT staff. The question is adoption. How are you going to take this information and make it actionable? How do you take this information? How do you position vehicles? How do you put GPS on vehicles and know where the vehicles are? So this is a progression, but you can't get this done unless the people in the field buy into it. And that means change management. Similarly, on videos, we have years of videos of a sewer system. How do you make it actionable? How do you make the people in the field understand that the work that they're doing, taking the videos, and how does it connect to engineering? How does it connect to asset management? Pipe sleuths, the process developed, software developed internally at DC Water to look at the videos and categorize the faults. And not everything has to be high-tech. A couple of years ago, we made a commitment to take a lot of our staff, almost all of them eventually, but start with the early adopters and move them from Excel to something like a Power BI dashboard, to start with dashboarding the data. We have a lot of data. All of us are data rich is action that we need. So we had different bridges. We had different silos within our operating groups, operations and engineering, and we had an issue with vehicles recently. How do you create a standard between different organizations so that you can solve a problem, which is how do you buy new vehicles? What is the utility of the vehicles? How do you share vehicles between different departments? And dashboarding is one way of doing it. It's not, like Sunil said, this technology hasn't existed, but to adopt it as a new technology for an organization that hasn't dashboarded this information, and how do you make it actionable? You got to use some change management principles and get the end users plugged into it. Big picture, new technology is fantastic, but if you want adoption of the new technology, you really need to look at change management. And you got to bring the people that are going to be using that technology and making it successful along with it. That's it. I think I've done it in 15 minutes there, Peter.
Very well done. Thank you, Salil. Up next, we have Dr. Ting Liu from Clean Water Services. Ting, you may show your slide or your presentation. Dr. Liu, or Ting Liu, is the business practice leader for digital solutions, where she leads and directs innovation and research and the development of solutions at Clean Water Services. And she's going to be presenting on the journey to digital solutions of the future. Take it away.
Thank you, Peter. Can everyone see my screen here?
Yes, we can.
Yep.
Okay. Thank you. Hello, everyone. It's an honor to be part of this discussion from utility perspectives to see where Clean Water Services perspective to get to the future for digital solutions and the leverage technologies. First is a little bit background about Clean Water Services. So our mission is to build for clean water for today and tomorrow. So we are a utility serving more than 600,000 residents in urban Washington County, which is just outside of Portland, Oregon. So we collect, treat, stormwater, wastewater, recover valuable resources through 4 treatment facilities. We also actively managing river flows and surface waters. And also we work on large scale watershed restoration on the watershed. So today I will talk a lot around the watershed management. How do we leverage technologies? And also today we have over 100 digital tools, and I think that's part of for utilities. We have a lot of these digital silos. The important key is to integrate all of them to provide that decision support for utilities. I love what Salil said earlier, is having that application opportunities to drive technology. So I'll talk about the challenges we have in Clean Water Services. So this is our river here we released to. It's called Tualatin River. It's a source for drinking water, also part of the irrigation and many recreation activities. However, it is very heavily managed watershed. So you can see the source of water in Tualatin River in summer. So this only 10, and it's almost 200 CFS. So that means in summer, we release around 70% of the water through our reservoirs and also the wastewater plant effluent to sustain this water quality and quantity here. And in order to do that, I'm sorry, I don't know why this automatically gets to the next. So in order to do that, it requires a lot of coordination and collaboration, both internally within Clean Water Services in different departments, wastewater treatment, watershed department, and also external agencies to manage this watershed. So it's a lot of the manual spreadsheet and also calculation here. So what I will talk about is how do we leverage the data and analytics using IoTs, Internet of Things, sensors, and also remote sensing like LiDAR and drones to help us to provide decision support on a watershed level. So this is a portal we developed internally, the Tualatin Watershed Portal. So you can see all these dots are water quality and water quantity sensors from different agencies. And also we maintain a reservoir. We have certain part of the water in that reservoir. So through integration between IT, OT, SCADA, and the engineering solutions, we were able to provide this platform to internal and external use to look at the flow management on a holistic scale. So you can see at any given time how much water we have within this reservoir, how much we can release. And also this is a USGS gauging station. We put the data from USGS, and also the data is showing here real time. So that eliminates a lot of going out to different sources to understand the flow information. We also have sensors internally maintained, so that really helpful to look at it together. And finally, we can also look at wastewater treatment effluent, because that's part of the puzzle to calculate how much flow we can release from the reservoir. So as you can see, the benefit of this is really help to look at the flow information on a watershed scale. The next example is on the remote sensing LiDAR and the drones technology. So a little background is about, so as part of watershed management, we do a lot of stream restoration projects, and this on the hundreds of acres. And we are required to monitor vegetation cover, vegetation health, and also canopy cover for our thermal management for the river. So in the past, it takes a lot of labor cost for people to go out and to inspect this vegetation health and monitor the cover. And they are only going there at the representative location, because you can't just go out to the whole watershed, monitor each tree and the green infrastructure there. So that's why we started to deploy leverage LiDAR information. So this is a tree canopy cover on a GIS map showing both 2007 purple and also 2014 on yellow. So you can see that quantitatively how much tree canopy cover we have increased over the years. That really provides the thermal management for our receiving stream. So it's reduced a lot of labor intensive and also provide that objective evaluation. And also we started like 5-7 years ago, we started to look at the drone technology. LiDAR helps you on a large watershed scale, but drone makes it more flexible, and you can fly over whenever you need to. So this is different pictures of resolution. You can see the 12-inch versus a 1-inch resolution picture from the UAS imagery. So this really helps us to get that granular information about how our stream restoration project does. So, and not only that, we have developed some of the algorithm to derivatively leverage the values of this data. So through this information, you can look at the vegetation health. You know, with the multi-spectrum camera and the algorithm, you can look at whether the vegetation is healthy, where it needs more improvement, and also quantify the impervious area. How much is the vegetation, how much is the impervious area, based on the imagery analysis. So this helps us to look at the integrated planning, look at land use on a large scale. So this is leveraging remote sensing to help monitor project information and tracking project progress over time. And then I'll talk about the IoT sensors. I think we all use a lot of real-time sensors, and the part is using commercial sensor stations is that it's really great and it's reliable. But when you look at the sensor network, it costs a lot of money to build that network. So one sensor we are deploying today with the external commercial stations costs us $10,000 to $20,000 to look at a variety of different parameters. So that has been a driver for me to look at what are some of the alternative cost-effective sensors that I could use to build that large sensor network. So we could monitor flooding during winter time, and also understand water quality on a more watershed scale. So this is a collaboration with the Liminotech consultant. So we started to explore this DIY approach. And I think it's very important, like Salil said, it involves the people is the first. So we have a team members, they are building the DIY sensor stations. So the heart of this is that you have your microchip and data logger, and this is only $60, and we leverage the quality of bareware sensors. We use open source algorithm and to build these stations, and then you have some accessories. So in the middle, the picture is showing you a soil moisture sensor we have built. So we have been 2 years into this journey. And it's been really great, and it's a big part is that change management, working with the multiple team members from engineering, from operations, and IT staff together. And it's really part of the major benefit is the modular approach, and we developed this dashboard, and this is a way to look at the data quality. We use queries, and you can see the IoT DIY sensor matching very well with the USGS sensor qualities. And with the software, we are able to look at field validation points. And when we did the validation, sensor validation. So this dashboard has been really helpful for data scientists, but for project managers and folks, and we use Power BI to look at trends, long-term trends, and also correlation between temperature, project information, and other things. So that's important to develop the fit-for-purpose dashboard based on different type of information we need to derive, but it's only the single truth there. Today we're continue expanding our DIY IoT capabilities. So as I mentioned early on, we started with a pilot project to monitor 4 stations. Today we have over 6 sensor stations in the creek, and 2 on the project side, and also 1 in the sewer line, monitoring DO, pH, conductivity, turbidity level, and temperature. So the team members felt comfortable doing this DIY approach, and really helps to understand water quality and flow in collection system and local rivers and streams. So we are using this information to calibrate our water quality model to assess TMDL development here. So I want to just bring back, digital transformation is a journey. And I think it's, I'll look at the 10 years back, and I think Sunil even earlier talked about that. I think the whole technology evolution has been decades, so the first is important to have the software, hardware, networks. That's a foundation. And then on top of that is the applications, databases, and integration we have built upon. And it's in the past, we have been always very security conscious. But so in the last 10 years, we have deployed business intelligence, including Power BI, reporting in the utility. And last 6 years, we deployed mobility using iPad. Today, like early on, we have only one iPad, I think 10 years ago or earlier, but today we have over 120 iPad. People rely on whether it's source control, field operations, wastewater plants using iPad to seamlessly monitor information. And then we started to look into cloud. And then the big part is the data quality and data management. So in the last couple of years, we started a hub. So I have been facilitating this data management effort to making sure we have the quality of data. And then also since last year, we want to bring the security at the forefront as well. Any technology evolution now requires a security mindset. So that's what we are working on. And also like I introduced earlier, the IoT technology for the last couple of years on the DIY approach. So the key takeaways here, I think it's important to align technology planning and implementation with the district mission and vision. And I see a skill sets involvement evolution too for future of workforce development. And overall, technologies provide accurate, consistent, and reliable solutions for solving business problems. And a big part I look at is from a technical standpoint is to building these platforms requires the integration with existing tools and platforms. So we see that a lot, and I think that's all I have. And thank you so much for the opportunity.
Excellent. Thank you, Ting. Appreciate the presentation. Next up, we have Jennifer Garigliano from NYDEP. Jennifer currently, excuse me, hold on one sec. She serves as the Chief of Staff for the New York City Department of Environmental Protection's Bureau of Water Supply, and is responsible for supporting the Bureau through program management and strategic initiatives. She's going to be talking about one of those initiatives today. Take it away, Jennifer.
Thank you, Peter. So I'm probably not your typical chief of staff. My role within the agency is also very technical. So in addition to managing the Office of the Deputy Commissioner, I also manage our wholesale water and community programs. I am the manager for our integrated water quality and operations modeling section. And I'm also responsible for overseeing the city's water rights on the Delaware River. So that includes interstate management and negotiations to develop a flow management program for the Delaware River, which is what I'm going to be talking about today. Just a quick overview of the presentation. So the New York City water supply system, it's very robust. It's primarily a surface water system. It consists of 19 reservoirs and 3 controlled lakes. It's broken up into 3 different systems in terms of our management. So the Croton system, which is the oldest system within our supply, it's mostly east of Hudson in the Westchester County area in New York. Then we have the Catskill system, which consists of Schoharie and Ashokan reservoirs. And then the Delaware system, which is the newest part of the system, which is Cannonsville, Papacton, Neversink, and Rondout reservoirs. Overall, we have a system capacity of 70 billion gallons. We serve 9.4 million people, which is half the population of New York State. We deliver about 1.1 billion gallons of water every day. And the source of the water, our watershed, is about 2,000 square miles in about 8 upstate counties in New York. So just a little bit on the history of the flow management in the Delaware River. It's very important to understand the history when going into these negotiations and when developing a program. So back in the early 1900s, the population within the city was just exploding. And we needed to expand our water supply. So even tapping into the Catskills with Schoharie and Ashokan reservoirs, it still wasn't going to be enough. And after much investigation and consideration, the city made the decision to develop the Delaware system. So the Cannonsville, Neversink, and Papacton reservoirs dam the headwaters of the main stem of the Delaware River, which creates a lot of interstate problems as the Delaware River supplies water to not just New York, but Pennsylvania, New Jersey, and the state of Delaware. So in 1925, the city and the state of New Jersey tried to get together to develop a compact to manage the water coming out of the New York City reservoirs. That failed to ever get ratified. In 1927, attempts were made again, including the Commonwealth of Pennsylvania, which also didn't work. So in 1931, a Supreme Court decree was issued that essentially put parameters together that managed the flow in the Delaware River. At that time, New York City only had Papacton and Neversink reservoirs. The city wanted to go ahead and build Cannonsville Reservoir. So in 1954, the decree was amended to allow the city to go ahead and put in the Cannonsville Reservoir. Again, parameters were updated and flow management program was updated as part of that 1954 decree. However, in the 1960s, we had a new drought of record. So that created a series of issues that wasn't necessarily anticipated or covered under the 1954 decree. So in 1961, Interstate Compact was created in conjunction with the federal government, and the Delaware River Basin Commission was formed. New York City is not a part of the Delaware River Basin Commission, but we are represented through the state on that commission. The DRBC has since created a series of regulations and flow management programs in conjunction with all of the decree parties that puts together flow management in place. In 1982, all of these parties got together to continue to discuss, the challenges and issues and advancements that were being made, and signed what was called the Good Faith Agreement. And it identified a series of studies and things that would be looked into to develop a new flow management program for the river. That's what all of these revisions are for the DP 7720 revised. In 2007, the decree parties again were able to take, advancements in technology and forecasting, and once again updated the flow management program for the river. So we now have in place what we refer to as FFMP, the Flexible Flow Management Program. And we will go ahead and talk about the latest version of the Flexible Flow Management Program, which is the 2017 version. So the 2017 FFMP is a document that is signed by the parties to the 1954 decree, which is all of the basin states and New York City. We'll get into that a little bit more on the subsequent slides. There's also several DRBC regulations. They have the Drought Water Code, water quality regulations, water supply charges, and a slew of other regulations for within the basin. Plus, each basin state also has its own laws and regulations, which makes flow management in the Delaware Basin difficult, as there are so many entities that are involved in this decision-making process. So in the 2017 FFMP, which was signed on October 21st, 2017, it included a phased approach to conduct a comprehensive analysis of flow management in the river. Knowing how many people were involved, how many different stakeholder groups, the different competing interests, we understand that to do a full-blown comprehensive analysis of flow management in the river is extremely difficult. So the 2017 FFMP identifies a series.
Hey, Jennifer, hold on one sec. Hey, for anybody who's watching, please put yourself on mute. Thank you. Continue.
Thank you. So the 2017 FFMP is broken up into a series of studies, and the overall goal of those studies is to identify big important pieces to the different parties to the decree. And the goal at the end of the 10 years of this program is to take all of those different pieces and come together and develop a new updated comprehensive management plan for the river. So it's broken up into 5 years. The first 5 years of the study is taking a look at a couple different things. The one that's most important for New York City is to be relinquished from the concept of that our releases during drought emergency from the Delaware reservoirs are based on the position of the salt front in the lower Delaware. Taking a look at increasing New Jersey's diversion during drought conditions and the increase of available storage for the lower basin. So the Office of the Delaware River Master, who is separate from the decree parties, the Office of the Delaware River Master was created by the Supreme Court, who oversees the flow management of the Delaware River. They're also working on their own processes and procedures. This first one is evaluating their use of the balancing adjustment. They're operating their study separately. It was just listed in the 2017 FFMP for awareness. So the second half, we'll take a look at what is called our method of calculating the excess release quantity. So the Supreme Court identified that there will be water in the New York City reservoirs that will not necessarily be needed for water supply. And that water is to be released for the down basin states to use. So that's what the excess release quantity is in a very basic definition. So as part of these studies, we are looking at and we are considering several things. Thermal mitigation for habitat and ecological protection. We have heard a lot from the fishing communities. There are several endangered species in the Delaware River. So all of those will be taken into consideration. Rapid flow change and mitigation. So the releases that come out of the Delaware River are mechanical in nature since they are coming from reservoirs. So toggling the releases and changing the flow drastically, either from a very low flow to a high flow or vice versa, can have impacts on habitat and ecological protection. We are also looking at alternate uses of the F.E. Walter Reservoir. Our hope is that they can switch their operations to forecast informed reservoir operations to help assist with low flow augmentation during times of drought emergency. We are looking at the 2 flow objectives that we currently have in the Delaware River, one at Montague that is managed by the Office of the Delaware River Master, and the one at Trenton, which is managed by the Delaware River Basin Commission. Drought management and flood mitigation are also going to be considered, and estuary and bay ecological health. So, like I said, this is a big undertaking and there's a lot of stakeholder consideration. There are a lot of parties and a lot of competing interests in flow management in the Delaware River. You know, our biggest concerns looking at these studies and creating a new plan is ensuring that long-term water supply reliability and water resources management is taken into consideration. You know, we want to make sure that New York City and our outside communities have water both now and in the future, with all things considered, climate change, sea level rise going on. We also want to make sure that water released has maximum benefit. So, you know, our studies have shown that water released early on in drought really doesn't have a lot of benefit. So we want to make sure that anything that we do, you know, maintains that water supply from New York City. It's also essential to ensure that all water released from storage provides substantial benefits. We don't want to see necessarily a lot of capital construction going on. We understand the timing and the cost that goes along with that, but taking a look at the storage that already exists within the basin and maximizing its use, we think could play a key role in flow management in the future. And we also want to see the development of a new salinity strategy for the lower basin. So getting most out of existing infrastructure, as I already mentioned, the development of a reliable salinity model to allow us to assess alternatives and issues that we may have in the future. You know, we want to see the 2017 FFMP salinity study progress, and the Corps of Engineers, in conjunction with ourselves and DRBC, is also undergoing the Effie Walter reevaluation study to see how we can use that water perhaps in the future to offset and augment releases downstream during drought. So, you know, just in summary, flow management in the Delaware River Basin has come a long way since its inception and since the 1920s. You know, we are making sure that we are taking a hard look at the quality of water plus the quantity of water as we go forward and trying to meet various needs. So we are trying our best to develop a comprehensive long-term flow management program for the river. As I said, those competing interests and those competing groups are very difficult to manage. But overall, you know, the groups have done a much better job over the last 2 years working together than we have in the past. So we hope that that relationship continues to go forward. Not being able to meet in person due to COVID has, I would say, slowed us down a little bit, and not being able to make progress. We do make better progress when we're able to sit together, you know, physically at the table and work on this together. So we will continue to work on this. You know, we will be making perhaps some minor adjustments to the FFMP at the 5-year renewal in 2023, but look to make that comprehensive change in 2028. So that's all I have, and then we'll get questions later on. Thank you.
Thank you, Jennifer. All right, next up we have Karen Sands. Karen Sands, the Director of Planning, Research, and Sustainability. And she is, excuse me, she's the Director of Planning, Research, and Sustainability for the Milwaukee Metropolitan Sewer District, where she's worked for over 19 years now. And she's going to be talking about some of the integrated and resilient approaches to the changing world at MMSD. Take it away, Karen. Thanks.
Thank you, Peter. I hope everyone can see my screen and hear my voice. I'm really pleased to be part of this. Thank you for inviting me. And I want to share with you just a few brief examples and stay within the 15-minute allotment. And as Jennifer reminded us, questions will come at the end. So the region that the Milwaukee Metropolitan Sewerage District serves is on the fresh coast of Lake Michigan in southeastern Wisconsin. It's part of a system that's home to 20% of the world's available fresh water. So it's super important to protect it, as protection of all fresh water is. What you're looking at is a bird's eye view. In the foreground is one of our 2 water reclamation facilities. It's at Jones Island. But there's a lot more to see in this picture, and it's about why this picture really illustrates for me why integration and collaboration and ultimately smart technologies are going to be really important to continuing to protect this terrific asset that we have. So just north of our facility, at the top of our screen, the screen that you're looking at is Summerfest Festival grounds. It's home to the world's largest music festival. Under normal years, it goes for about 11 days, but in this oddball year, there was no Summerfest, among other things. The spit of land to the east or right of Summerfest is what we call Summerfest Island. It's a barrier island that we built with excavated tunnel rock from MMSD. The waterway in between Summerfest and the Jones Island plant hosts what was an annual event in 2018 and 19, but not this year, called the Cream City Swim. We actually swam in the river a couple of miles. And farther north of all this is an active marina and beach, and farther west and south is a very dense mixed-use commercial and residential set of neighborhoods, as well as downtown Milwaukee. They're all adverse to sewage odors, among other things, as well as stinking cesspools, right? So it's really important that we protect not only public health and the environment, but then also the economic investment and the environmental quality that's all around us. Just as an aside, we've been partnering to study climate change throughout and across our region for the past 15 years. And increasingly partnerships and equity are important lenses in this context and need to be integrated into our smart one water approaches. But I'm getting ahead of myself. I'm gonna move to the next slide. Just real quick, I'm going to talk about MMSD just on one more slide. And then I thought I would be a little funny and try to riff off of Charles Dickens' A Christmas Carol and have something about the past, the present, and the future, but didn't really work. There's no Ebenezer Scrooge here. So I'm just gonna still focus on three things, past, present, future, but I won't put Dickensian language in. So today I'd like to talk about our climate change vulnerability analysis and resilience plan that came from the past, our 2050 risk-based facilities plan that's very much present, and then the role of artificial intelligence to change our ways in the future. My one slide infomercial here. This is the MMSD region. We serve just over 1 million customers. There are 28 customer communities, so we own the downstream end of the system and 2 water reclamation facilities. We also have a tunnel storage system that's 521 million gallons maximum capacity that we use to hold combined water in that area with the diagonal orange or yellow stripes, and sanitary sewage in the remaining part of the system. But we do a lot more too. We manage out-of-bank flooding. We make an organic fertilizer. We make a lot of our own energy. And then we supplement all of our systems with green infrastructure, both in the separate and the combined areas. They do different things. And we have about 40 million gallons of capacity that's available every time it rains, unless there are back-to-back storms. And then we also protect acreage in the upstream areas extraterritorially of our 411 square mile area. And we put easements or restrictive covenants on those properties, all in willing situations. And we've protected over 4,500 acres through that work. So first up, in 2014, we finalized our climate change vulnerability analysis, and the study used a risk-based approach to climate change adaptation. So we could look at how climate change impacts could affect our systems at a level that we'd look at existing and planned facilities and operations. So the 2 primary drivers of climate change impacts here, as in many parts of the country, are changes in temperature and precip. This hierarchical diagram, that's probably too small for you to see, but it's just meant as an illustration. It's on the right. It branches through some of the changes, showing potential responses to temperature change and precipitation. And then goes down into very specific responses in the blue boxes. The studies report has a lot of diagrams like this, and they all look, like somebody used PowerPoint back in the day to create them. Not as high tech as it probably would be now, but very effective in showing and connecting the kinds of changes that we have been seeing to potential issues in our facilities. So from there, and together with our consultant, we considered the likelihood and magnitude of each physical response to our facilities, primarily through modeling, and we looked at 4 climate change precipitation scenarios. We also recommended through this action no regrets activities, meaning no regrets, you don't have any regrets if you do it, and adaptations. These are things that we should consider even if the climate change scenarios that we modeled don't come to fruition. No regret strategies include things like, just looking at trends, using corrosion resistant materials, And then fascinating for me when I learned it was that our Jones Island plant that I showed you on the first slide, it was built so long ago and on such unstable ground that piles were driven, lots and lots of piles. They were wood. Wood piles can last for hundreds of years if they stay wet. The lake level right next to Jones Island controls the groundwater level at Jones Island. So if the lake were to go down in level, the groundwater could go down and those piles could be exposed. So watching lake levels and how they affect our Jones Island facility and the wood piles that are there is very important for us to keep on top of. We then updated the overall analysis in 2019 to see what we'd missed. And then we used the 2014 and 19 reports as foundations for a long-range facilities plan. Our studies of vulnerability on the last slide that I talked about were all internally focused to MMSD's facilities, really just looking what we needed to do with our real estate. But given our regional context, we're super municipal, we have 28 municipalities. And given that and the location along a beautiful and Great Lake, we in our commission, they're our governing body that sets policy and spending for us. We decided to consider resiliency in a regional context, not just MMSD, but with partners and stakeholders. And that's because climate change, as you all know, doesn't respect boundaries. And so we know that what we do can't happen in a vacuum. So the resilience plan covers regional, social, and economic characteristics and forecasts in the context of climate change forecasts. We know that changes in climate are likely to cause prolonged periods of heat, less severe winters, and also more precipitation will fall on frozen ground during those less severe winters, floods, and heavier precipitation events with longer periods of drought in between. I hope this is all not true, but it's looking like it is. The risks associated with these changes we are seeing are all connected to, and so too is our collective way forward in thinking about how to tackle regional resilience. Our process in writing the plan was a little complicated, but the complexity was worth it. Other studies were consulted, especially the 100 Resilient Cities effort by the Rockefeller Foundation. We had community resilience building workshops that the Nature Conservancy developed a template for, and they were held to identify and prioritize climate change risks to average stakeholders, municipal officials, electeds, NGOs, and everything in between. We also interviewed stakeholders and developed a digital community survey. And so with all these consultations, we identified risks, and then there was a series of whittling them down because there were so many and categorizing them. In the end, we came up with 3 visions, and I think about 20 or 24 very important top scoring risks with an action plan to address all of them. In some cases, we would be the lead in addressing them, and we're doing that. In other cases, we're the support. And in some cases, we're not even involved, but they were things that were important to the region. So the visions, the 3 visions we came up with are on the slide. I just wanted to point out Vision 3 has about 5 actions in it, including a criticality audit, and then I think Sunil mentioned, or the speaker after him mentioned Power BI and dashboards. Using dashboards like our Power BI dashboards that we've developed for with asset management and for our gray infrastructure facilities were also something that was recommended that municipalities adopt. So now to the ghost of, now to present day facilities planning. We have a long-term horizon of 2050 in a plan that's in review with our regulator now. We took the risk-based approach used in our vulnerability planning, and we took that one step further. That was initially tied to asset management, and the two got a divorce at some point, maybe a year and a half ago. So the asset management foundations in the first bullet still laid a good foundation for our facilities plan. But in order to get the plan done on the time horizon we wanted to, facilities planning went forward and diverged from asset management. So at MMSD, the asset systems, both in our asset management planning and in our facilities plan, they're broken down into 4 types, but we also consider the integration between the 4. So we have our conveyance and storage, which storage is our deep tunnel and our inline storage system. We have water reclamation and biosolids. We have water course and flood management, and we have green infrastructure. And as I said, we look at these 4 systems independently and then together to see if 2 or 3 or 4 of them have effects on one another, as they often do. So I won't go through this whole process, but suffice it to say that we think our approach was smart and flexible in the face of an uncertain future. Some people put a lot of stock in forecasts, and I'm not an engineer, I'm a planner. So I remind my very smart engineers that these are just forecasts, and when they're not attained exactly in 5 years, it's okay. So the smart thing that we did, because forecasts are simply based on the best data you have at the time, we, instead of assigning years to needs that were identified to address risks, we came up with triggers, things like population growth in sewer sheds, or increases and decreases in industrial pollutant loadings. Those are things that will help us know when to start a project. And the reasons for starting a project may be things like capacity to meet existing or future demand, physical mortality, things wearing out that connects with asset management, level of service, like non-capacity goals, and then also economic efficiency. So we have 4 categories there as well. So the role of artificial intelligence. I wish I had something really inspiring to say, but I will tell you our story, and I'll tell you that we're on a path to hopefully being able to talk about this and implement it at particularly at our water reclamation facilities. We need to keep an eye on the future. That's what's smart to do, but in government, there are often hurdles. Hurdles are not necessarily roadblocks or brick walls, but the lesson on this slide is about hurdles and our need to overcome them as government. And sometimes they're in place for a very good reason too. So our research director and I are interested in leveraging artificial neural networking, the industrial Internet of Things, and artificial intelligence to optimize water reclamation performance. These things are no longer futuristic, and they're becoming common practice in some industries. We could use these technologies for things like predictive analytics for root cause analyses when we have a process upset, things like the development of real-time process control measures to optimize water reclamation performance and minimize costs, and things like optimizing O&M cycles to allocate resources more effectively in the system. So getting a little more specific, some examples are our discharge permit that the Wisconsin Department of Natural Resources issues to us has mass limits that cannot be exceeded in our effluent. We need to stay below those mass limits. And sometimes there's a bit of guesswork, but we feel that with artificial intelligence in a trained model, we would be able to have a more consistent level of pollutants, or minimizing the pollutants in our wastewater, and also save money and energy. Another example, we'd like to right-size the amount of disinfection chemicals. What comes into the plant often needs a different level of disinfection by time of day, by time of year, by any number of things. And then also another example could be to remove unnecessary preventative maintenance. Maybe we're maintaining things too frequently. Maybe we're not maintaining them enough. These would be important things that we think artificial intelligence could instruct us on. Innovation and publicly owned treatment works need not be enemies, and we're working on that, but it can be really slow going when you're working on the edge in government. Sunil reminded the presenters before you all came on to this presentation that AI was around in the 1970s. The big difference, if I understood him correctly, is that we now have all this data, so we can implement AI more intelligently, and our AI models are more accurate and useful. So we conducted a proof of value study, and in doing so, the consultant that we worked with told us that millions of dollars of savings could be obtained according to them, but we're risk averse, right? We have ratepayer money to play with, and we can't play with it. We have to make sure we make good decisions. But because there's a lot of intellectual property involved in AI, especially when the approach is on speculation to us, it's hard. The level of trust between government and the entity, in this case AI, it's hard to create and sustain. And then even when staff professionals find that level of trust, we still have our own internal procurement and legal hurdles. So for instance, we need to bid things out. So if we were to take a proof of value concept, we would probably need to bid it out. To bid it out, we need to be able to tell the bidding community what we know already rather than restarting again, but we can't because there's intellectual property involved. Also, we have a unique complication maybe. We have an operating contract. We own our facilities, but Veolia operates and maintains them. In the contract, we specify shared costs for technology and for operations, and it's not 50-50 always, and shared benefits, also not 50-50. So there would need to be a lot of negotiation and, and then determining, does the contract allow this? And if not, is there stomach for an amendment? Because we would potentially be asking them to cooperate in a study and then change some of their operations as well as their financial picture, potentially. So this is a picture of downtown Milwaukee where pre-coronavirus, people, pre-coronavirus, people flocked to area rivers. And this is a picture of what downtown Milwaukee looked like when people didn't wear masks and could walk along the waterway or stop at a riverwalk bar or motor there in their boats. Very, very active place in the summertime. But the river was not always this urbanly beautiful. In fact, I looked online before this presentation and found so many references to the river being a cesspool or even a stinking cesspool. But that's not the case anymore because of primarily modern wastewater treatment, but then also partnership activities, education and outreach that changes people's behaviors and any number of things. So the river has significantly come back. I mentioned there's an annual swim in the river. You wouldn't have done that 10 years ago. So what I'm trying to say is we collectively have solved some really big problems in our past, and I have some confidence that we'll solve the issues that I see, at least with my organization, in adopting artificial intelligence in the future, and we'll be able to move forward with more smart technologies and smart one water approaches. It's just going to take a little time, but smart people will figure it out. So thank you for your time. Oh, and I forgot to mention that all the reports I showed are available on our website. It's not there, but it's so simple. It's mmsd.com. That's it.
Great. Thank you, Karen. All right. Next up, we have Anas Malkawi from Hrsd. Anas is the Chief of Asset Management, where he oversees an engineering division that manages the asset management program, which encompasses about $5 billion worth of wastewater infrastructure. And so Anas is going to be talking about some of their approaches to Smart One Water at Hrsd. Thanks, Anas.
Thanks, Peter, and thanks, Sunil, and everyone at the Swim Center. And good morning, good afternoon, good evening, wherever you are in the world. Thank you for participating in this conference. It's been very enlightening to me hearing all the presentations before me and in the past couple of days as well. Definitely like this opportunity to learn as much as I share some of our initiatives. So I wanted to talk about Hrsd's Smart One Water initiatives that we have going on. So just a quick overview of Hrsd. We're a wastewater public utility in Southeast Virginia. We own and operate 16 wastewater treatment plants with a combined capacity of about 250 million gallons per day. We serve 18 cities and counties, and I say 18 plus because we're actually in the process of taking some of the smaller communities around our service area to be part of our organization as well. We took over 2 localities last year, and we're in the process of taking over 3 more localities, small communities, in the upcoming year. So we serve about 1.8 million population. Again, that's a 1.8 million plus, because we're constantly expanding our service area. Our mission is to protect public health and the waterways by treating wastewater effectively. And our vision is that future generations will inherit clean waterways and be able to keep them clean. So when I was preparing this presentation and thinking about Smart One Water, I wanted to kind of dissect those 2 concepts, the smart and the one water. And when I thought about smart, I'm like, well, smart in what? And the first thing people think about when they think of smart these days is they think digital transformation. They think smartphones, they think smartwatch, all these different concepts. And that's great. That's definitely something that we're pursuing. And we are expanding the way we use technology to be more efficient and optimize our processes. But at the same time, we can't forget about our roots as a technical and analytical organization. We definitely have to be smart and continue to do our research and development to optimize our processes. The other thing is the customer focus. We definitely have to be smart in terms of how we engage our stakeholders and how we communicate with them, because at the end of the day, we cannot operate as an organization if we're not affordable, and we cannot do what we do without the funding from the ratepayers. And if the ratepayers are not able to afford the rates, then we cannot, it is not a sustainable business practice. And finally, the 4th thing that I thought about was organizational culture. How can we make sure we recruit, retain, and train our staff to be technical and analytical and continue to provide the level of service that we need to provide? We focus on our values and leadership and collaboration, and as well as diversity, equity, and inclusion. So, I heard in the last couple of days, and you even heard it this morning about, a lot of the harder things to do as an organization is not really the digital and the technical aspects. It's really the soft side of things, the people aspects of things. That's really the hard part. So in a way, that's probably the toughest area to be smart in, is the soft side of things, the people side of things. But as long as you have the people, process, and technology areas kind of covered, then that's the core way to actually be a smart utility. And these are the 3 areas that we're definitely trying to focus on. So the rest of this presentation, I'll focus on these 4 areas and how we're being smart in each of these areas. In terms of the digital smart, just like all other organizations that you heard from, we're implementing, smart metering, smart sensors all over our service area, all over our infrastructure. Ability to remote control our pump stations and treatment plants, or if we're not able to remotely control it, at least automate those processes as much as possible. Big data is definitely a buzzword in the past 5 to 10 years or so, and we're definitely seeing the increase in the volume of data and the velocity, how frequent this data is coming in, and the variety, the different types of data that we're getting in, and how do we leverage software and technology to be able to bring in all of that volume and variety and velocity, and be able to process it and give us the conclusions that we're looking for. You heard about AI and machine learning and deep learning, all of these areas. I'm kind of like Karen, I'm a little skeptical, and we're not necessarily in a place where we can say we're advanced in this area, because it definitely, just like she said, it needs a lot of data, and we're still in the process of kind of digesting all that data and figuring out how we can, what's the logic, what are the calculations that we need to do to be able to automate certain things. And it's machine learning, but we need to feed it a specific logic, and we're getting a lot of data, but we need to build it in a way that actually the machine can actually do it on its own. We're also exploring digital twins and how we can leverage that in our organization. We are using BIM, Building Information Modeling Systems. And we're leveraging that for a lot of different areas within our vertical facilities. And we definitely use GIS for a lot of our linear assets as well. And cybersecurity obviously is a huge area in terms of how do you make all of these areas happen securely. And interesting to say that we are in Hrsd, we were hit with a ransomware about 3 weeks ago. And to this date, we are not up and running. So for the past 3 weeks, I had no access to our entire network. Luckily, our treatment plants and treatment processes are on Linux, and everything that was impacted was on the Windows side of it. So we're still able to convey the wastewater with no issues, but our customer and billing system is down. Our CMMS is down. Our email is even down. So for the past 3 weeks, it's been very, very interesting in terms of how we can operate, especially in a COVID environment where 40% of our staff are working from home and now no access to the network. It's really making it hard for anyone to do their jobs. And in terms of the technical and analytical, how we can be smart about that, we're definitely, incorporating the life cycle of assets, how we can be smart about how we plan, design, construct, operate, maintain, and dispose our assets, our infrastructure, how we can enhance our research and development to make sure that we optimize our processes, how we can be sustainable. And one thing that we are doing is, as an organization, we calculate our carbon footprint equivalent using the EPA calculator in our region. So we look at what are the specific areas that we use that impact the carbon footprint from an organizational perspective. And you can see the electrical use is the most, and then you see natural gas and others. But we also monitor it at a work center level. So each work center is contributing to the carbon footprint equivalent. So how can we, reduce, for an example, in this Virginia initiative plant, it's not our largest plant, but it's one of it is the most in terms of the carbon footprint equivalent. So we can monitor that, track it, and see if we can find better ways that we can reduce the carbon footprint from that specific treatment plant. And from a resiliency perspective, Hampton Roads as a region, like I said, we're in Southeast Virginia here, and this is a map from USGS showing the coastal vulnerability of sea level rise. And New Orleans is the first in the nation being most vulnerable, and the second is the Hampton Roads region. So we definitely are impacted by sea level rise and climate change. The frequency and intensity of hurricanes and flooding events is definitely on the rise. So it's something for us to be mindful of and plan for in the future. So the customer smart, how can we be smart in terms of how we deal with our customers? So it starts with, identifying the stakeholders, whether they're residential, commercial, industrial customers. We also have local, state, federal partners. We're home of the largest Navy base in the world. So that's definitely a federal partner that we deal with, as well as EPA and some other regulatory agencies. Advocacy groups, environmental, fishery, all these different groups that are impacted by our processes, as well as professional associations, WEF, AWWA. We feel like we have an obligation to make sure that we contribute to the industry as much as we learn from it as well. And beyond that, there are definitely much more stakeholders that we can that I can mention. How can we enhance our communications, outreach, and public education? Obviously, using social media is the most efficient and effective. That's where your customers are. That's the quickest way to communicate your message. And specifically now with the cybersecurity issues that we've had in our network being down, that's been the most efficient way to reach our customers. When I go on my Facebook news feed right now, I can see a message from Hrsd saying that, what the issues are with the cybersecurity and any updates from that. I see that from my Facebook newsfeed. And we definitely want to identify the levels of service of each stakeholder. So each stakeholder had their unique circumstances and what they would like or desire from us as an organization. So identifying each level of service for each stakeholder is definitely important for us. And that's definitely something we're doing. And it all boils down to affordability. How can we do everything we do in an affordable fashion? And in terms of the organizational culture, how can we be smart in that area? Obviously, talking about our mission and vision and values, recruiting the folks that kind of meet that mission and vision and share those values with us, and retain those people that do share those values with us, and train them to make sure that they have those skills, the technical and analytical skills, or the operational skills, or the administrative skills, all the different skills that are needed for our organization. Having good leadership, we do a lot of training, leadership training, and the leadership is not just internal, how do we lead our staff, but it's also externally, how do we lead the industry in terms of research and development and in the smart area and in the One Water arena as well. Diversity, equity, and inclusion. One thing that I mentioned on Monday is we are trying to transition the organization. Everyone probably heard the culture fit concept, but we're trying to transition to a culture add. How can, not just that we want to recruit and retain people that fit our mission, vision, and values in our way of the way our organization is, but we also want to add to our culture. We want to bring in folks that represent our stakeholders that can add to our culture, not just fit our culture. Because if you just want to have a culture fit, then you're kind of stagnant as an organization. Whereas to be progressive, you need to recruit and retain people that can add to our culture. And obviously collaborating with all of our stakeholders to make sure that we meet everyone's needs and not just our organization's needs. There's a misspelling there, but we have a training called Your Role in Quality, where every individual in the organization talks about kind of what their role is to the organization, whether they're an admin assistant or whether they're a treatment plant operator. Everyone has a role in the organization, and they kind of talk about what their role is and how their role contributes to the success of the organization. So that's kind of on the smart side. Now, why One Water? So everyone here is, in the water industry, so everyone knows water is life, and water does not recognize political boundaries or organizational service areas. And water is expensive to move, and then clean it, and then move it again, and then clean it again, and just move it again. It's a repeatable process, but it's very, very expensive to continue repeating that process. And water is our best friend and our worst enemy. If as you can see from the pictures here, that we rely on water for recreation, for food, for fisheries, for all these different things. But at the same time, they could be our worst enemies in terms of flooding, in terms of home damage or anything else. I have an engineer that works for me that has a funny thing that she says is she loves water, but water hates her because every time she goes back home, there's some kind of problem with a leak or mold or something. So as much as she's passionate about her work, water finds some way to affect her personal life. Sustainability, as an environmental organization, obviously we want to make sure that future generations will inherit clean waterways and be able to keep them clean. And affordability, one thing that we're trying to do is do long-range financial planning. The old age of 5-year CIPs is just not cutting it anymore. We need to plan out 30, 40, 50 years and beyond to make sure that we are investing in the right infrastructure at the right time to be able to be sustainable. The bond rating is very important to us. We're able to take advantage of low interest loans that way. We're able to take advantage of WIFIA and state revolving fund loans as well as an organization. And this is a picture of the EPA administrator 2 months ago, giving us a WIFIA loan for about $225 million. And that's just a portion of the money that we've been provided by WIFIA. About $800 million total is what we'll be given at the end of the program that I'll be discussing later. So one mind-blowing fact, I'm a big fan of Neil deGrasse Tyson, and he has a quote that says, there are more molecules of water in a cup of water than there are cups of water in all of the world's oceans. And he kind of continues on to say, just think of every time you drink a cup of water, those molecules that you're drinking probably have passed through the kidneys and bladder of Hitler and Stalin and all these other people. So basically what I'm going with this is there is no new water. It's all one water. The water came here to Earth from some asteroid or something in the past, and it's been the same water. It evaporates, it precipitates, and we all understand the water cycle, but there's no new water. So we have to be thinking from a one water perspective, because it is just one water. So what I'll talk about now is our SWIFT program. That's a Sustainable Water Initiative for Tomorrow. So I'll quickly discuss the water issues of coastal Virginia. First one is the depletion of groundwater resources, including protection from saltwater intrusion, because we're on the coast. So the Atlantic Ocean definitely brings in a lot of salt water into the aquifer. There are water quality concerns. We're also on the Chesapeake Bay, and there are definitely from EPA and Virginia Department of Health, definitely a lot of regulations in terms of restoring the Chesapeake Bay. There are local water quality issues as well from stormwater. The localities here are under MS4 regulations to make sure that they reduce the runoff and build some BMPs to reduce that runoff. But there's a waste load allocation that we consider. So how can we look at the wastewater, the stormwater, and the drinking water from all aspects to restore the Chesapeake Bay? Sea level rise, as I mentioned earlier, we're very vulnerable to sea level rise in this region, but it's also compounded by land subsidence. And what I mean by that is the aquifer that's beneath us, there's a lot of withdrawal from that aquifer, which is causing the land to actually sink because of the lack of pressure in there. So this program here will hopefully inject or recharge that aquifer with clean water and be able to actually build that pressure back in the aquifer. We're also under a consent decree to reduce and eliminate SSOs. So that's another water issue here in our region. So this graph here kind of shows the 50-year plan that we have, or from a prediction or from a projection perspective. Right now, this is the groundwater contours. You can see here, these are two areas in red where the aquifer has been recharged from two industrial facilities. And in 50 years, if we recharge the aquifer after we treat the wastewater to drinking water quality, then the groundwater should rise and hopefully eliminate these two red areas here. And this is just a quick picture of the aquifer in the past. Back in 1927, we used to get water from here, and then in 1932, they had to keep tapping that pipe to get the water because the pressure wasn't going up to here. And in 1933, they kept poking holes until in 1937. Now they're here. And then actually now we're actually pumping that water from the aquifer because there's not enough pressure, hydraulic grade line to actually bring the water up to the surface. We have to pump it up, which is, like I mentioned earlier, very expensive. So these are all regional issues that require regional solutions. So the SWIFT concept is that, right now, the drinking water treatment plants pull from the aquifer or from the river, they distribute it, the wastewater comes out, we collect it, or the localities collect it and pump it into our interceptor system, which conveys it to our wastewater treatment plants. And we typically, right now, we discharge it into the Chesapeake Bay or one of the rivers or the ocean. But the SWIFT concept is that we would add an advanced water treatment process that would treat that wastewater to drinking water quality, and then add certain chemical components to it to match the geochemistry in the aquifer, and then recharge the aquifer with that, and then hoping that it would build that pressure to reduce that saltwater intrusion coming in from the ocean, as well as reducing the rate of land subsidence and potentially even rebounding the ground level, with the ultimate goal of having 6 plants up to 100 million gallons per day that we would recharge the aquifer with. So the benefits that we would help the bay by significantly reducing the amount of nutrients such as nitrogen, phosphorus, the Hrsd discharges to the James, Elizabeth, and York rivers. We would replenish our dwindling groundwater supply, allowing this natural resource to remain productive for generations to come. We would fight sea level rise by reducing the rate at which land is sinking in Hampton Roads, and we would protect groundwater from saltwater intrusion due to a shrinking aquifer. and support Virginia's economy by providing businesses with the water they need to operate. So we built a research center for our SWIFT program. And the focus of that research center is research and development, obviously, as the word says. And what we're researching is the treatment technology. What are the best treatment technologies that we can use in that facility? And this is currently what the process is. And we're also measuring the impact on the ground level. And we're also using that facility to use it as a digital twin for not just from a design and construction perspective, but also how do we operate and maintain the facility using a 3D model that you can use through the life of the facility. And this is what we use, the BIM technology, and we use augmented reality for that facility during the design and construction, and now during the operation and maintenance phase. We do a lot of public outreach. That's what the facility is also designed for. So this is a picture of inside of our facility. So you see a lot of people here, and it kind of explains everything that I talked about earlier in terms of the aquifer and the challenges that we have, and then what the SWIFT concept will actually provide the community with. And it's also used for training our staff. We're not planning on adding a lot of new staff, so we want to make sure that staff, our treatment plant operators, are also cross-training into pretty much drinking water operators. So we're rotating our operators into that facility to learn the SWIFT processes, so that once we go to full scale, that we have trained operators that can operate our treatment plants, our new treatment plants. So how do we measure the?
Sorry to interrupt you. We still have another presenter, and we've got to also hopefully have a discussion. I hate to cut you off, but we're behind schedule.
Okay.
Yeah. If you, yeah.
Want me to wrap it up here, or
Yeah,
I can stop
good.
here if you want.
Yeah. If you have any final comments, that's fine. We want to make sure we stay on schedule.
Okay, we can stop here.
Okay. It's great stuff. And I know people will get a chance to see your slides after, but I want to make sure David gets a chance to present as well.
Sorry if I ran a little over.
It's okay. Thank you for a very informative presentation. Okay, last but not least, we've got David Leach from American Water. David is a senior project engineer, and he's been with American Water for 13 years. He helps to manage the risk assessments and resilience initiatives across associated with compliance with America's Water Infrastructure Act, AWIA. And David, I'll let you take it away. Thanks.
Great. Thank you, Peter. Quick check, everyone should see a red fire hydrant, so I appreciate that. Thank you, Peter, thank you, Sunil, for including me today. Good afternoon, good morning, across the many time zones. Thanks for joining today. I know somehow the year is wrapping up, so everyone is super busy, and your time is appreciated. Like Peter said, I'm Dave Leach from American Water. I'm going to talk a little bit about resilience, a topic we've heard a few times today, which is great. I'm going to talk about it from the standpoint of asset management across the very large footprint that is American Water. This is who we are. AW is the largest and most geographically diverse publicly traded water and wastewater service provider in the US, literally coast to coast. And this is who I am. I'm a project manager assessing risk, ensuring compliance specifically with the AWIA right now, and defining resilient systems in the toolbox that is available to our systems. So how do we define resilience? We've heard it a bunch of times today. The Army Corps defines it this way: the ability to anticipate, prepare for, and adapt to changing conditions, and then withstand, respond to, and recover rapidly from those disruptions. The anticipate can be the hard part there, so preparation for recovery is important. Note the key words in the definition are changing conditions and disruptions. Assets deteriorate over time. The environment is constantly changing. Malevolent threats continue to change rapidly. These are all types of risks that can impact our ability to provide service. And when disruption occurs, it's how we planned, prepared, and then react to a change that is the measure of our resilience. Oh, excuse me. How is the risk landscape changing? AW faces a dynamic threat environment, mostly due to our large geographic footprint. So let's just look at one type of threat, natural hazards. Since the 1980, the US has sustained 258 weather and climate disasters where the overall damage reached or exceeded $1 billion. In 2019 alone, there were 14 weather and climate disasters, each with losses exceeding $1 billion. And of course, 2020 has been eventful with the most active Atlantic hurricane season on record, 7th costliest on record. There were 30 named storms from the middle of May to the middle of November even, and over $41 billion in damage. So no matter what the threat, water needs to be on for a community to recover. So we need to identify risks and implement a smart asset management strategy across this large footprint to prepare for that. And that's why resilience is so important to American water. So at the regulation level, to help drive risk management and asset management, the America's Water Infrastructure Act, AWIA, was passed in 2018 and provided several requirements. Didn't change the Safe Drinking Water Act, but it was the most significant update since 1986. Most notably, the AWIA strengthens US EPA's efforts on overall asset management, focuses on risk, resilience, and then finally the ERP, the Emergency Response Plan reporting requirements. Like any good act, the AWIA recommended a standard for the assessment. The standard provided is the RAMCAP J100. I'm sure a lot of you are familiar with it. It has 7 simple steps for assessment, I like to say: asset and threat characterization, identification of consequences, vulnerability, and threats. And then the final 2 steps, identifying specific risks for your system and their management. This process results in a pairing of assets and threats. This is a very valuable data point that can be applied to other studies and tools. Take a quick look at what that means for us. The Act groups systems by population and then requires 2 steps for each of these groups or rounds. Step 1 is to conduct the assessment. And then step 2 is to update or create, if not available, an emergency response plan, an ERP, to specifically address those risks that were identified. Here in this slide, we can see the impacts of these rounds for American water. AWIA compliance is built around identifying systems specifically by PWS-ID. So in the first 2 rounds, there are about 40 systems that we have to assess, our largest systems, which represented about 78% of our total population served. In round 3, we've got about 90 systems to assess. That only represents about 20% of our overall population. So if you put that together over 3 rounds, we're assessing 130 systems, but about 98% of our customer base. And by assessing so much of our customer base, we can help define why communities are safer and more resilient with American Water as a service provider. So a few notes about the types of threats. It's helpful to consider overall asset management planning, to consider assessing risks that are outside of the threats prescribed by the J100. This helps capture the actual scope of threats that have the potential to impact our mission continuity. This is aged infrastructure, compliance-based risks maybe, or other natural threats not considered by the J100, such as drought. One thing omitted by the J100 is compounded risks, which 2020 is a great example of. First tropical and now winter storms all occurring during pandemic response, which is certainly a complicating factor. AWIA required assessments are the bridge from planning into doing, and these assessments are the measure of resilience and therefore one input into our asset management strategy. However, we do cram a lot of inputs into that strategy. One of those inputs that we leverage is called the Utility Resilience Index, the URI. It's an industry developed rubric. It's part of the J100, and it's another tool in our toolbox. The URI is a calculation that provides an assessment of a utility's ability to absorb and address an incident and then return to normal operations as quickly as possible. It's part of every assessment we do. And it's calculated as the weighted average of 2 sub-indices with some complicated math behind it, technical capabilities and a financial capabilities, roughly an 80-20 split between the two. The thing to consider about the URI is it's a data point that provides a compass heading, but not really a GPS destination on a map. The compass headings are here to help us guide the development of standardized risk score for each individual system, which is super useful in prioritizing projects, and inputs for asset management plans, studies, capital plans, maintenance plans, and then finally that ERP. It is a numerical score. It's not like my 14-year-old's math test where 100 is expected or perfect. 60 to 70 is normal. Over 80 is very good. And since the sub-indices of URI can be a lot to absorb, it may be easier to look at them into these 3 categories: asset resiliency, people power, and community resilience. People power category, we see documentation, training elements like NIMS, the National Incident Management System, and cross-training teams to build resilience. And these items are very tightly linked. Think of it this way: a systems ERP isn't really written for the teams that are there every single day. The ERP is written for someone who's not familiar with the system and may be rotated to that location to provide assistance during an event. Asset resiliency category highlights the components of the URI most influenced by a robust asset management and capital planning. Standby power, storage, spare parts, not the Bruce Springsteen spare parts from the Tunnel of Love album, but the parts that are hard to find, the things you don't want to break until after you retire. Asset management efforts like comprehensive planning studies, condition-based assessments, and capital plans are all crammed into that component. Community resilience is measured by calculating some local data, and this part of the calculation may seem somewhat external to us, but it tries to identify how quickly a community can rebound. So in terms of defining resilience, part of the answer lies in asset management and the planning tools that build up to that management. Essentially, these tools are helping us think about resiliency before it is needed. It's a deposits before withdrawals equation. It fosters a resilient mindset to integrate improvement plans into daily efforts like operations planning, and then larger scale efforts like capital projects. These resilience efforts help us to optimize the design of our countermeasures to these potential threats. And a system should have a deep toolbox to help them move that needle on resilience. This includes capital operational efforts, like we mentioned, and some are mentioned here. It's important to keep in mind that even if funding is not immediately available, that risk doesn't go away. It continues to exist. Risk is always there until it's fully mitigated. One of those tools that we leverage into that cone to help us define resilience is our asset risk management process. Once you have the data points we've discussed, a hallmark of a resilient system is not only identifying and addressing the risks, but finding a way to communicate those risks up and down our leadership continuum. This is our risk register, an example of it, which is used to communicate these risks. And then the tool captures and defines risks so we can understand it, especially risks to which we may have become overly accustomed to, see them every day and aren't really reacting to them. The tool considers multiple inputs, including the output of the OWIA required assessments. And a best practice of this tool is to make it a living document, review it with a standard cadence, focusing on high risk consequence outcomes up here in this top quadrant. The risks can then be reassessed and moved across the dashboard as countermeasures are deployed. And some hallmarks of our assessment tools, it considers social consequences, economic consequences, environmental consequences. So in closing, there are so many elements that build into the definition of resilience. Documentation like planning reports, assessments like the OWIA that we talked about, and tools like the URI and our asset risk management process. If I was asked how a system can improve their resilience quickly, I would say to always start with the people power. At American Water, with over 6,000 water professionals, our people power is our strongest suit. So we pursue training like NIMS and cross training and develop robust plans with those teams. Following this multifaceted path forward helps ensure communities are more resilient and that we're always prepared for the next threat. So with that, I would thank you and ask everyone to be safe through the holiday season. Peter, back to you.
Great. Well, thank you, David. Appreciate you condensing your presentation given the time frame. So now we are at the group discussion section of this of our session, and I wanted to open it up to the to anybody who's attending to be able to ask questions openly to the group. I've got a couple of questions lined up. If there's, but I'd like to let the audience give them a chance first to see if we have any questions, and also just a big round of applause to the presenters who just talked for the last better part of a little over an hour. Appreciate your guys' time and what you just shared. So opening up the floor, yeah, please feel free to speak. Okay, I'll kick us off with a question. How about that? And also feel free, if you want to put it in the chat to everyone, that might be a good way to be able to make sure we see what your question is. I would recommend that. So to the group, one common theme, you all live and breathe managing strategies to improve resiliency in your organizations. In the past year, we've experienced an unprecedented social pandemic that has literally changed our world. I'm curious, how has this societal crisis informed, changed, and reinforced your view, and perhaps the initiatives you're working on that are focused on resiliency?
Great. Who wants to go first?
Go ahead, Bill.
Go ahead, Ting.
Well, okay, so I'll start. So for us at Clean Water Services, I think the pandemic really brings the forefront for the resiliency. There's the operation resiliency, there's the workforce resiliency, there's the facility resiliencies. So we are look at this, revisit this again. We did have a business continuity plan, but it's it's been many years. So we are looking at this again holistically. And I think in terms of smart water, so we are also look at business continuity plan from an IT standpoint. So what does that mean if there's a cyber attack and things, as we heard from other speakers? I think that's really important that the utilities now look at from a different lens.
Yeah, and considering what happened to Firefly less than 24 hours ago, cyber is a huge concern to all of us. And we're using Teams and Zoom a lot more. I think we're opening ourselves up a little bit more to the attacks. So that's, I'm sure it keeps our cybersecurity guys up at night. But overall, I think in terms of productivity, it's interesting. I think productivity of a lot of the staff has actually gone up because they save hour and a half commuting time each direction. And they just put that back into the work. Not that we want to continue that, but what it does has shown us is the front line that's often gets neglected is the one that took the brunt of this impact because they have to be in the field. Customer service has dropped off because we're trying not to get them to interface with the customers as much directly one-on-one. So it's a mixed bag.
I'll echo that. It's a mixed bag. We, on the one hand, we had a business continuity plan. It even had the word pandemic in it, which probably if I read that a year ago, I might have laughed. But we were gearing up for the Democratic National Convention here in Milwaukee. So we had a plan for how people would be able to work from home for the most part for that week, but no way were we ever going to let people do it for more than that week, just because of traffic. There were going to be more than 50,000 people here, and then, you know, it really didn't happen here. But it's interesting how the, you know, stay-at-home orders hit, and then all of a sudden, everything we had been talking about and thinking about was useful, but it also changed because now we're expecting people not to come in, except if you, you know, inspect work outside or you work in the lab. We have permit compliance issues. It's going to be interesting when people come back. Some are more productive at home. I am not. Some people have small children. I don't have any idea how they do it. But I think what I've learned is, and I've always treated all my staff as individuals, but now there's so much individual. They have so many different wild things happening, people dying in their families, having to take care of children, daycare's opening and closing. So they're working, you know, till 2 a.m. so they can get their 40 hours in. It's just, we're going to have to be more flexible going forward.
You know, at Hrsd, we were very fortunate that last year we rolled out Surface Pros for our entire organization, and we thought that was really helpful to gear up for this type of situation. Wow. And then, you know, one thing that we pride ourselves in Hrsd is, you know, our adaptive management style. You know, instead of having a lot of rigid documentation, policies, procedures, we try to be adaptive to situations, and that's how we actually overcame the pandemic situation. We focused a lot on you know, making sure that we have our critical processes identified, and then once we said, okay, we're short in staff, okay, what do we absolutely need to do? What are those levels of service for those different stakeholders, and how do we make sure those levels of service are actually met with the limited staffing, with the challenge we have? And also emphasized the need to, you know, all of us are thinking about the digital transformation. And then once the pandemic hit, it really put an urgency behind that digital transformation. You know, we really can't depend on people as much as we used to. We need to have data telling us what to do or automate a lot of processes in the event that we can't have the amount of staff that are needed. Emphasize cross-training, making sure that folks in one treatment plant, if we have a outbreak in one treatment plant and we have 30 people that can't report to that treatment plant, how do we make sure we bring an operator from a different treatment plant that is cross-trained to just come there and be able to operate that plant with no issue? And then once we got hit with the ransomware issue, it really showed us that that dependency on the digital world really cripples you. I mean, when it comes to being able to do our business operations without this digital platform that we use on a day-to-day basis. So we're definitely a lot of lessons learned are going to come from 2020 for sure. And then, you know, hopefully more lessons learned will be shared next year.
Peter, you are muted.
I'm muted. Anybody else want to speak to that? Yeah.
Sure. I mean, New York City got hit hard. I mean, real hard, very in the beginning of all of this. You know, we had, you know, probably been hit the hardest. But, you know, this is really speaks to a testament to the staff that they are firm believers in the mission of delivering clean water to the city. You know, we did split our staff just like everybody else. Anybody who was able to telecommute started doing that, which is something that we at DEP never allowed before. And I can't see us ever being able to take it fully back. But we've had staff reporting this entire time, water treatment plants don't run themselves. You know, the filtration plant doesn't run itself. The UV plant doesn't run itself. And they have been reporting through all of this, and service to the city never once was interrupted because of the pandemic. So the resiliency of our staff, I think, has been the biggest blessing in all of this, to ensure that hospitals had the water that they needed to treat patients, that restaurants still got water that they needed to do takeout, that people who were now stuck at home had the water that they needed to eat, drink, clean, and, you know, take a shower and never once even think about it. So, you know, our staff, probably the biggest, in my opinion, next to the healthcare workers, the utility workers, are probably some of the biggest heroes to come out of this pandemic.
Wow, well said. Thank you. Okay, well, I think there's a question that was brought through, and this one is to Dr. Liu. What was your main motive to move forward with a do-it-yourself IoT solution and not an off-the-shelf solution, or going through a development process with a vendor?
Yeah, that's a great question. So I think the main motive is really the cost driving this DIY solutions. So as I mentioned, we already have a lot of commercial solutions, which is a cost at least a few $1,000s to tens of thousands of dollars. And then often you have to add telemetry costs, the dashboard cost. And so that's all adds up. So that's why we thought, how can we find a cost-effective solution and also a modular approach? So we could leverage, you know, now you have LoRaWAN network, you have a different, we already have a lot of different type of dashboard, like a Power BI, GIS, and other softwares too. So the main driver is really the cost and also modularity. So we are able to bring all this sensor data into one place versus this digital silos. The other part, I would say, it's a culture shift. So we did this transformation, and I'm leading our digital solutions group, and the group is the IT group in the past. So the intent there is also to create this collaboration between IT and also operation and engineering staff to co-create the solution together. So this become a great effort for us to build the sensor stations together. The IT staff knows more about what is a TMDL, water quality, and then help facilitate that common language and bridge the silos. I would say a lesson learned from this DIY approach is our costs really get down. So we're less than a quarter of the commercial sensor cost. However, there is additional cost to building the knowledge we need to learn to build the sensor stations. We also have learned how to support the sensor stations, because you lose that support from the commercial vendors as well. So there is a learning curve. I think on a scalable solutions, it's worth considering, but it's not a one-size-fits-all solution for every utility.
Great, thanks. Okay, well, I know we've got a few more minutes, and
Peter, if I could just add to Ting's, I mean,
yeah,
got some very brilliant people there. I'm always jealous about our staff, but we went down that road, and what we decided is our focus needed to be in eliminating the data silos and not going with manufacturers that would lock in their data. And our focus moved to creating a data lake within the organization, because sensor is just one part of the data that needs to go in there to do analytics. There are so many other pieces of data that need to feed into the data lake. So we've been working with different manufacturers to have them create APIs that would open their systems up. And if there's any manufacturers on the call here, Xylem, for example, we should be talking about, it's great when they create their own dashboards, and that's where their creativity comes in, but they should also have an API to pull the data out to a data lake for other people to use.
great.
Peter, I have one question.
I'm sorry, Sunil, you're not allowed to ask questions.
Oh, okay, I will keep quiet.
I'm just teasing.
Yeah, so for all the presenters, it was great presentation. I learned a lot. So one question is, which NSF is also asking, we are trying to create a new organization, which is, we are calling it a Smart One Water. So how you see this new organization? Is it a threat, or you feel it is important? Because there are many organizations out there, the Water Research Foundation, then a lot of federal agencies. So how you see a new organization coming in the area of a Smart One Water, trying to work with all the stakeholders?
So Sunil, one of the things we found out is there are limitations in the water sector. We are extremely good on process. We are extremely bad on equipment and maintenance. So we actually expanded out to industry, and we partnered with organizations that work with industry on the maintenance end. The same is going to be across the board. So while the organization is great, we need to be careful as to who we pick for partners, because there's more technology in other fields.
I guess the only fear would be that if there's a new organization that with the goal of breaking silos, sometimes just like a new department in an organization kind of with the goal of bridging gaps and breaking silos, all of a sudden creates a new silo. So that would be the only threat or fear that I would have, is there will be a new silo. But as long as there's, mutual benefit to the industry as a whole, us as an organization, and I'm sure everyone, all the speakers would agree, we all have a common goal, for one water. We're all in this for public health and in the environment. So if that common goal is there, then I don't see any issues.
Okay, so we are almost on time, Peter. So I really want to thank all. We are not face to face, but still we can clap.